Hello and welcome to another one of these ADD videos. Today we're going to look at a couple basic examples of empirical molecular problems. So the first of which is just to illustrate the concept of how to find the empirical formula given moles, which I doubt they'll give you, but just in case. So if we have some unknown compound and it's got X, Y, Z, and it's got some subscripts we don't know about. So what we do is we divide the smallest moles. In this case, 1 mole is the smallest, and it goes into 1. So for the X, that means the subscript is going to be 1. And then 2 divided by the smallest is going to be 2 for the Y. And then 5 divided by the smallest would give you 5 right there. Okay, so the point was just to illustrate, once you got moles, divide by the smallest one. Make sure you're within that plus or minus 0.1 or 0.2, depending on what you're taught in class, range of a whole number. In these cases, I designed it to just give you whole numbers. And then those are your subscripts for your empirical formula. All right, moving on. So here we have a problem in which you're given grams and molar masses. Well, the only additional step between what we did before and what we're doing now is to find the moles. And if you remember, a mole is when you take the grams times the molar mass, which is grams as well, per mole, which the mole then flips up in the numerator. The grams will then cancel, leaving you moles. So if you did that, if you divided 10 by 10, in this case you'd get 1 again. For the X, I guess I'll write it up here. So it'd be 10 grams divided by the 10 grams per mole. So then you flip and multiply and you get 1. And then here, when you do it, you're going to get 30 grams divided by 15 grams per mole. And you're going to get 2 moles. And then finally, when you do 45, 1.125, which I'm going to say is good enough for government work in this case, because I'm not trying to go down that road of multiplying by a whole number. We're just trying to learn the basics here. So 1.01 or 1.125, sorry, can be approximately 1.0, which then would give you an empirical formula X, Y, Z. Because the smallest one is 1 here and here, when you divide 2 by 1, you get 2, so it'd be 1, 2, and 1. So on this one, I gave you the molar mass of some compound that has a molecular formula based on this empirical formula. What that means is that the molecular formula is some multiple of the ratio of 1 to 1. So the way you would do that is you would first get the mass of this empirical formula. So we got 1 of X. X was 10 grams per mole, so we got 10, plus the 2 Y's, which was 30, so that's 60 when you get 2 of them, plus the 45, gives you a molecular mass, I'm sorry, a molar mass, not molecular mass, of the empirical formula So if we take that 210 divided by the 105, we see that this molecular compound is just twice this ratio, the empirical ratio. So we have 2 times 1 is 2, 2 times 2 is 4, 2 times 1 is 2. All right? So what did I do? Well, I took the molar mass of the molecular formula and divided by the molar mass of the empirical formula. That gave me this whole number. I took that whole number times each one of these subscripts to get this molecular formula. All right, so you can see it's not too bad. Always go to moles, divide. Make sure you check the more advanced videos in which when you divide here, this number will be outside that plus or minus 0.2 range. In that scenario, you're going to have to do some multiplying by a whole number, and I'll go over that in a different video. So practice, practice, practice. You got enough to get your foot in the door. So do some problems. Watch the other videos. Thank you and have a nice day.